Okay, so we also reviewed eccentric impacts. In the first half of the course, we talked about central impacts, but now we had eccentric impact. Now, what's an eccentric impact? Well, you've got some type of rigid body here moving in, we'll say this direction, and another rigid body moving in some other direction, and these two collide, and we'll say this point here is going to collide with this point here. And so what this notation is saying is, this is the, let's see, so we would take the velocity, let's label this point A, and this point B. So here's A, B, and then this is the velocity after the collision. So the primes indicate after the collision. I'll write this up here. After collision. This is the velocity before the collision. The E here is known as the coefficient of restitution. And remember, we kind of talked about two limits. E has to be between 0 and 1. The coefficient of restitution is between 0 and 1. And if we're talking about a coefficient of restitution near 0, it's something like clay, where the objects will deform and they'll stick together. If we talk about a coefficient of restitution that's near 1, it's more like a rubber ball. So you've got completely elastic, recover all the energy. Now let's look a little bit closer at this collision when these two objects collide. So I'll draw this. Here's point A, and it's colliding with point B. Let's see, so we had A here, B here. We have a velocity for A that looks something like this. It's going up in this direction, and B is going in this direction before they collide. And let me zoom in here so I can kind of draw this in more detail. And what we need to do is consider the normal components of the velocity for A and B. And so let's see, if we took a look at this is the velocity of point B the instant before it strikes, we would break that down into a normal component, so the part that goes right here, and then a perpendicular component, and the same with A. So we would, for A, we would have a normal component and a perpendicular component. And so velocity of A is this, the net velocity, and we break that down into this normal component and then a perpendicular component. So the sum of those two, of course, is equal to total velocity of A, and velocity of B is equal to this vector. We break that down into the normal and the perpendicular. Now the equation we wrote only depends upon the normal component. So let's look back at that. So for this eccentric impact, this little n here indicates the normal component. So we've got the velocity of B after the collision. We take the normal component minus the velocity of A after the collision. We take that normal component, subtract the two, and that should equal E, the coefficient of restitution, multiplied by this quantity, which has to do with the velocities before the collision. But again, we're just taking the normal components for the velocity of A and the velocity of B. And so this is eccentric impact.